Hello friends, welcome to Coding Interviews channel. Hope you are doing great. If you haven't subscribed to the channel, please go ahead and subscribe. I have created bunch of playlists to cover various categories of problems such as dynamic programming, BFS, DFS, stacks, queues, and so on. Please check them out. I have uploaded the code for this particular problem to the GitHub repository. You can get the link from description below this video. So let's jump into today's problem. Longest substring of all vowels in order. A string is considered beautiful if it satisfies the following conditions. Each of the five English vowels must appear at least once in it. So that's our first condition, right? So to get back to the actual description, right? So there are five English vowels, right? So basically, in this particular representation, all of them are lowercase. So let's assume for an instance the string is formed of all lowercase, right? So let's say they're all lowercase, right? And we have five vowels, right? A, E, I, O, and U, right? And it said must appear at least once in it. So if a string has to be beautiful, right? All these vowels and five vowels should appear at least once in it. And that is first condition for the string to be beautiful. The second condition is the letters must be in sorted in alphabetical order, right? So that's another thing. So they should be sorted in alphabetical order. So basically, alphabetical order is A, all A's should come before E's, and all E's should come I before I. All I's should come before you, and so on. Basically, right? So from that we can derive basically. Let's say if this is what the list of vowels, right? Let's say A, E, I, O, U. That they are the list of vowels. That means so vowel of I is less than vowel of I plus one, right? Simple. So the value of A is less than I. That we know that already. So that condition still holds for us, right? So if all A's must come before all E's, right? Then this condition should hold true. But that is not just enough, right? We will have to go further and see, okay, are we guaranteeing there is only one A in the string? No. That's the reason why all A's, if there are a bunch of A's in the beautiful string, right? All of those A's should come before E. That's a second condition, right? So that's what is alphabetical order. All A's before E and all E's before I and so on, basically, right? So there are some examples that are given here, right? So we can probably pick this example and look at it. So I have more examples as well, right? So in this particular case, all A's, so see, all A's are before E. So far that is good. And E, there is only just one E. That's good. As long as E appears after A, it is good. And I, so before I, A and E should be there, right? Yes, that is actually good in this case. And here it is O. So before O, all A's, E's, and I's should appear, right? So far so good. And at this point, U. All A's, E's, I's, O's, and U's appear before U. So that means this is a beautiful string, right? So there are another examples that I gave here. A, E, I, O, U. Basically, we just have only one instance of each of them, right? And here A's are bunch and E's are bunch, but I, O, U is not that many. And I have some invalid examples. So here, even though A, I, O, U, right? So they are in order. Basically, that is in alphabetical order. But there is one thing that is missing here. Why we are saying invalid? It said all must appear at least once in it. So here E is missing. That's why we say it is invalid. So we cannot call that as a beautiful substring. So similar to this A, E, I, O, U also, and here also. And we can form basically all these different substrings as well, right? So in this case, one thing that is missing is they are not in order, and there is I also missing in it, right? So even if you add I, let's say, so you have all these elements. Basically, all the vowels are present in that, but the second condition, the letters must be sorted in alphabetical order. That is not the case in this, right? We have A, E, I, O, U in this particular string, but they are not in the alphabetical order sorting. So we cannot call this as a beautiful string, right? So it's not just that, right? So basically what we have to find out is a substring. So basically let's go look at the example one, right? So in this particular case, obviously if you look at the whole thing, right, when you say all A's must be preceded by all E's, right? So you do have A's happening here, right? And I is here. So they're all jumbled upon, right? So the whole thing cannot be a beautiful string, but we are tasked to find out the longest substring, right? So this is a given string. By satisfying the number one and number two, what is actually the longest possible, right? So that's the so we know that they're all lowercase, just for an instance, right? So we will say okay, there is a lowercase, and we also know if there are five vowels, each vowel, the I vowel of I is less than vowel of I plus one. So this is also true, right? Assuming this is the case. But if there are a bunch of them, right, what we are going to do is, as long as vowel of I, this is not a basically not vowel, but if you say the string, let's say this is a string, right? Str, right? So in this case, what we can say is str of I should be less than or equal to str of I plus 1. So, but is that enough, right? So, but is that enough? So, for example, right, A, E, I, O. So, in this case, it satisfies, right? String of I is less than or equal to string of I plus 1. It satisfies. But can we call this as a beautiful string? No, this is not a beautiful string because we are missing U from it, right? The first condition is missing. Even though it satisfies the second condition, first condition is missing. So this is how, I mean, basically we are coming up with what are the conditions that we essentially need, right? So this is the first condition, right? Let's write. So condition one, it need to satisfy this, right? But as long as it satisfies that, right, we are good. But when it is satisfying, what is the starting point and what is the ending point? So we need two more things: starting index, right? Starting index and end index, right? If we know that, then that is for condition one. And for the second condition, in order to make sure all the five elements should appear, right? So since this is just five elements, right, and English alphabet has only 26 letters, so if we want to implement the five letters, right, we can simply go for a hash set, right? So hash set key can keep track of the characters which are appearing in that particular I to J, basically starting index and ending index. So whenever you see five elements, right, that means you have a substring, right, a substring which is satisfying both the conditions, right? That is where you have the start index and end index, right? So that means you will have substring, right? That is a base substring which is so far longest. You don't know whether that is the completely longest in the entire substring, but so far longest, right? So while we keep track of the so far longest and keep updating, basically we keep going by a sliding window. So we are going to use a sliding window approach here, right? So as long as our sliding window, while we move from obviously the first character till last character, right? So we will be moving in a sliding window fashion, and whenever we have five elements in the hash set, right, hash set dot count, right, is equal to 5, then we have satisfied our both conditions and we are good. That is when we will say, okay, I have the substring which satisfies both conditions, but it may not be the longest. But we will continue our search, right, with a sliding window. So that's one approach, right? But do we really need to use the hash set is another question. So there are only five things, right? So there are five alphabets which are vowels. There is nothing wrong in using the hash set as it is holding just 5 characters all the time. There is not a big overhead, I would say, right? So, but every character you will be doing the search through the hash set whether hash set has the character or not. In order to not do that, all we need is how many times the character really change, right? How many times the character really changed. So if the character changed 5 times, right, then we are good, as simple as that. So while we are traversing, right, so let's say starting from A, at A we have seen one character, that's good, so that is one change. And then when E appears, that is another change, 2 characters change. And then I, there is a 3 characters change. So but when we are at A, the first condition goes away. It is no longer str of I is less than or equal to str of j. So what we are going to do is we have to reset our sliding window. So our sliding window starts again from this A. Okay, our sliding window started again A, and we can check how many are there in the hash set previously for the previous one, right? A, E, I, only 3. So it doesn't satisfy the condition 2. So let me write the condition 2 also here, right? So it doesn't satisfy. So we go further. A, good, and A, that is same. Basically we saw it already. I, that is good. O, that is good. But again A came. So that means so far we have seen 3. The hash set has 3 elements, right? So in that particular case, we will have to reset our sliding window. So our sliding window starts here again. A, so far good. E, so far good. I, so far good. O, so far good. O, U. So far we have seen all the 5 vowels. So that means so far this is the longest substring, right? So far that is the longest substring. Whenever we are at U, we will count, okay, we have longest substring so far. That's it. So that is how we will move up our sliding window. So there are only 2 conditions that we are going to employ. One is with string of I is less than or equal to string of I plus 1, where I is the index, and we will keep track of the hash set, and hash set should have 5 elements in it. So the other way is, instead of using hash set, right, so we can keep track of the count of distinct characters, right? So whenever the character changes, we will update this count. So whenever this equal to 5, that means we have seen all the 5 vowels in that particular uh, sliding window. So that's how we can proceed further. So let's go ahead and look at the code for this particular problem and then try to understand, right? So the first thing, as we said, it should have all the elements or all the characters appearing at least once. If the string length, that means if the input string length is less than 5, right? Obviously, there is nothing. I mean, we cannot have a beautiful string in that. So we will just return 0 straight away. And next. So the letters so far we have seen we are initializing to 1, and current max and max we are initializing to 1 again. So at this particular point we are initializing to 1. We will see how we are going to return the actual length if we did not manage to find a beautiful substring yet, right? So we are starting from 1, right? We are starting from 1, not the 0 character, right? So we are assuming, okay, current max is already 1 and letter so far is already 1, right? That's why we are starting with the first character instead of 0 character. And we obviously we will have to go through the entire string, right? So this is the condition 1 that I was talking. String of I should be less than or equal to string of I plus 1. Yes. So here I changed a little bit. Basically I minus 1 should be less than or equal to I. So it's similar basically, right? So I minus 1 is less than or equal to I. Since I am starting with 1, right, I minus 1 will never be throwing any exception or whatsoever, right? So that's good. So as long as this condition satisfies, right, we will be able to move further. So that means whatever the alphabetical order that we want to ensure, we can ensure and we are good. As simple as that. And if at all the word, I mean the characters are not equal, then we are going to increment the distinct letters so far by 1, right? And then we will incrementing the current max, basically the length of the current sliding window. And if it is not, right? So if you see a character, let's say in this example, right, after A, you saw I. That is where we will come to the else part and check if letter so far is equal to 5. If it is 5, that means whatever the substring, the sliding window that we have seen so far is a valid one. In that case, what we are going to do is we are keeping track of the max and we'll compare the max with the current max and update the max. So that's what we are going to do. And once we encounter this, we are going to reset our counters. Letter so far to 1 and current max to 1. So this will be done for the entire word, basically the string, the input string. At the end, we need to have another check like this. Why? For example, if you have I, basically a like this, right? E I O U. For example, this is the string. In this case, you have got all these so far, right? But if you don't, you have already exhausted, right? But if you still are having the letters so far to 5 and you want to output the right answer, then you need to have this check at the end. So if the letter so far is 5, then you are going to check whether you have any new maximum length, right? That's where you are going to update the maximum. So this is really important here, right? Because we have initialized max to 1, right? We have initialized max to 1. If it is max is still 1, if max is still 1, then we are going to return 0. Why we are going to return 0? Because in order to have the string to be beautiful, all 5 vowels must appear at least once. So if all 5 vowels appear at least once, right, there is no question of max or longest substring of length 1. So even though we are initializing here to 1, we have to make sure we don't return 1 because 1 is not a possible answer at all. The minimum possible answer for this is 5. As simple as that, because all of them should appear at least once. So the minimum possible answer would be as simple as A, E, I, O, U. That's it, right? That's the minimum possible answer. That's the reason why if max is unchanged, basically, we have assigned to 1 and we are checking. So if at all it is equal to 1, then we will return 0. Otherwise, maximum. Whatever that is there. So this is how the entire code works. So let's go ahead and look at the time and space complexity for this, right? So time and space, right? So assume input string length is basically n, right? So we are going through the entire string once, right? So that means it will be order of n, right? So we are going through the entire string only once. That means it is order of n. That is the time complexity. And for the space complexity, are we using any any extra space here? Yes, we are using a few variables, letters so far, and current max and max. So apart from that, we are not really using anything. So irrespective of the length of the input, we are just using only 3 variables here, right? So that means the space complexity will be a constant time. That's a constant space that will be represented by order of 1, right? So we will say, okay, space complexity for this particular problem, I mean for this particular code is constant space and time complexity is order of n, where n is the length of the input string, right? So if you have any further questions, please post them in the comment section below this video. I'll get back to you as soon as I can. As I said, I have posted this code to the GitHub repository. You can get the link from the description below this video. If you haven't subscribed to the channel, please go ahead and subscribe and share among your friends. Please click on the bell icon so that you will be notified about my future videos. Thank you for watching. I will be back with another problem very soon. Till then, stay safe. Goodbye.